Hey everybody, welcome back to my bench. Do you remember this little guy that we worked on a little while back that had the bad Zener diode over here and blown out resistor and a bad capacitor and stuff? This is a RF amplifier for one of my FM transmitters, and the complaint was, he brought it back and he said, the other engineer here said that it was not putting out any power. Well, okay, well, that's sad, but we'll check it out. So I went down to my other transmitter and I brought this beast back with me. This is an MX-15 Harris FM exciter, one of ours. It was in service for a very long time, and we just stepped up a little bit, but this thing is quite large for a 10-watt transmitter, basically. But that's the way things go in radio, or used to anyway. If we look over here at the meter, we can see, because if we look down here, I've got the forward power pushed in, which we're reading on the 20-watt scale, and you can see I'm putting in right now approximately 8 watts into right there, and through this little, as the CBers say, 2-pill amplifier right there. I'm monitoring the voltage out of the power supply that we fixed, and we have right at about 8.67 volts. We're feeding it with about 43 volts out of my little power supply here, and we're drawing about 2.16 amps, about 93 watts, somewhere around there. And according to the good old bird watt meter, we're putting out 10 watts on a 25 watt 100 megahertz to 250 megahertz. It's a 99.7. It's close enough. Anyway, we're putting about 10 watts. So we're going to crank up this little pot. I just replaced this little 10K pot, which goes over here. It replaces the potentiometer that's in the transmitter itself to vary the output of this. So we're going to crank up our little pot here to about 25 watts, which is about what we run it. We're running about 2.85 amps, about 123 watts. I don't want to leave this running too long because my little power supply here is only good for about 3 amps, but we are definitely putting out 25 watts with an input of, we're still sitting at about 8 on that bottom scale there, about 8 watts. What's our reflected look like at this point? Yeah, not perfect, but it's less than, it's about a half. Alright, so I would say offhand that this little amplifier is working. We don't run it very hard. We run it at about 14.5, 14.4 volts, which is what I'm running at right now. And it's working. I'm running this into an old flat pack dummy load back here. Antique. But hey, it works. So there we go. It's working. I don't know what to say to him, but I guess we'll let it run on low power for a little while and see what it does. Hopefully I don't burn up my little power supply. Hey, we'll come back in a little bit and see what it's doing. Okay, so after running this thing for a little while, I just did the poke your finger around to see if there's anything hot test, and this transistor right back here got hotter than the hinges of Hades. Now, I expected to get kind of warm, or at least warm, because it's dropping. It's about 60 watts of that it's dissipating. This one up here didn't get near as warm, but it's only dropping by the schematic about 20 watts. So I don't know. All the other parts are good, but since this is a 24/7 deal, I'm going to dig into the spare parts. I'm going to replace that transistor, this transistor, and both of these ICs here. This is a little LM358 op amp that they use to control the disable of the RF disable on the transmitter. This one is LM324 voltage regulator. So I'm just going to replace those guys, bring it back up, and see if it gets as hot, because I can't find anything else wrong with it. We'll see. Well, one thing I noticed is I took this thing out of here. Here's the transistor, and here's this. The goop, the what do you call this stuff? Yeah, heat transfer material is no longer material. It's just, boy, it's hard to do this. Yep. It's dry. It's dusty. So I have a really good thinking that maybe that's bad. But let's give this thing a test, just for the fun of it. Well, that's not going to help me any. That's not going to read if there's any leakage in it or anything like that. I don't have that kind of a tester. But we're going to go get the other ones and put them in anyway. This is Motorola MJ11028. And 31st week of 87, this thing's been working 24/7 ever since then. Interesting. Wow. Yeah, 87. That's when I put this thing in. Well, okay. We'll be back. Okay, sorry about the noise, but we got this thing keeping it cool here. Well, I've replaced that transistor, that IC, and that IC. Gooped them all down good. Gooped this guy down too, because the goop had turned into non-goop thermal compound, if you want to get exact about it. And right now I'm putting out about 15 watts, 11.2 volts, and 43 volts in, basically. 2.5 amps and 107 watts. This thing is not what you would call efficient. And I got an input right now of about 8 watts. And this transistor, oh yeah, ouch, big old fan, whipping a bunch of air around. It has this huge heat sink on here. See there? This transistor is not what you would call cool, but it's also not burning the skin off the end of my finger either. I'm going to let it run this way for a little bit and see what it does. I think it's okay. That transistor there, just barely warm. That transistor there, however, quite warm. But like I said, it's dissipating 60 watts. So that's a bunch. I'll let it run for a little while and we'll see what happens. Well, okay. It's been running a good 15 minutes now, almost 20. And it's still putting out its 15 watts. Still 11.2 volts and about 2.48 0.49 amps, so 2.5 amps. And this transistor, well, I mean, it's hot. I wouldn't want to leave my finger on it, but it's not, you know, it's hot. But you're meant to run that hot. But usually this thing has a 100 CFM fan going across it all the time. What I got here right now, I have no idea. The heatsink, stone cold. All I can do at this point is stick it back in the transmitter and see what she does. Well, there we go. We'll see how she works. So, hey, if you like the video, give it a thumbs up, and thanks for watching.